Dear students, today we will learn about the onion diseases and its management. So, first of all, in the introduction, let us see some importance of the disease. Onion Allium cepa is cultivated throughout the world. India and China are considered to be the major onion growing countries in the world. A variety of diseases and disorders affect onions production. Most of the diseases are caused by fungi or bacteria, whereas disorders may be caused by adverse weather, air pollutants, soil conditions, nutritional imbalances, and pest control products. Sometimes several diseases and or disorders can be present at the same time. Important fungi diseases that are responsible for low production in India are stem phylum blight, stem phylum vesicarium, anthracnose, Coleotrichum gliosporoides, purple blots, Alternaria pori, Fusarium basal rot, Fusarium species, pink root of onion, Pyrenocita terrestris, downy mildew, Peronospora destructor, and Sclerotium sepivorum white rot. Downy mildew. The causal organism is Peronospora destructor. Let us see how the symptoms looks like. Initial symptoms are leaf tips go yellow, often as spots and patches. Next, a fine whitish down develop on the infected patches and cover entire leaf surfaces. They soon become a dull brown purple when the weather is humid enough. All the foliage is attacked and eventually destroyed. It also infects floral parts and may be carried with seed. When conditions are dry, the spots do not develop into the purple stage. Bulbs from infected crops will develop problems if they are stored. Infected onions are small, soft, and do not store well. So, this is about the symptoms. Now, we will go for the epidemiology of the disease. The pathogen overwinters as oospores and also persists as mycelium in infected bulbs. Initial infection needed temperature of less than 22 degrees centigrade, optimum 13 degrees centigrade. Presence of dew on the leaf surface or relative humidity of above 95%. The spore of the fungus produces at night, matures in early morning and disperses subsequently. The fungus may destroy the onion foliage in a field at almost 4 infection cycles. Now, after this, we will learn about the management practices. First is the propagation of the onions should be from healthy fields. Infected crop debris should be removed and destroyed after harvest. Dense population of plant and windbreak should be avoided. Avoid poor drained soils, late plantings, and application of higher dose of fertilizers. Spraying Mancozeb 0.2% or Ridomil Gold MZ 0.2% or phosphatyl aluminum or pyraclostrobin or azoxystrobin or dimethomorph is recommended. Onion lines like IC 48045, IC 32149, IC 33617 and DOP2 are resistant and can be used for disease resistant source. Next important disease is the purple blotch. Purple blotch of onion is caused by Alternaria pori. Purple blotch is reported in onions, garlic, Egyptian onion, Welsh onion, leek, and probably other species of allium. It is one of the severe diseases of onion, infecting both bulbs and seed throughout India. Now we will learn about the symptoms of the disease. Initial symptoms are first appearing on leaves or seed stalk with small water-soaked lesions that quickly develop white centers. Later on, lesions enlarge under favorable conditions, coalesce and become zoonate and brown to purple that extend upward or downward. During the moist weather, black fruiting bodies were observed on the infected area of the leaf or stem. Older leaves are more susceptible than young leaves. Similar symptoms were observed on the stalk. Resulting seed may not develop or shriveled. Now we will learn about the epidemiology of the disease. The primary source of inoculums is dormant mycelium, which remains alive in diseased crop residue. The fungus can survive on the diseased plants up to 12 months. Airborne conidia act as secondary source of infection. Bulbs can carry the fungus, but viability is lost within few months. Dew or rain plays an important role for sporulation or infection. It can grow at a wide range of temperature between 6 to 34 degrees centigrade, but optimum at 25 degrees centigrade. Continuous light helps in increased lesion size. Increase in the nitrogen dose decreases spore germination on leaves. So this is about the epidemiology of the disease. Management. First one is the long crop rotation with unrelated crops. Good field drainage, reduced plant density, fungicides like mancozeb 0.25%, captafol 0.2%, metalaxyl, dinocap, hexaconazole, propiconazole, difenoconazole are effective. Some resistance line like IIHR 56-1, IC 48059, IC 48025 and ALR can be used for resistance breeding. So this is about the disease. Next important disease is the Fusarium basal rot. It is caused by Fusarium oxysporum forma specialis Cipe. Now let's see how the symptoms look like. The initial symptoms are yellowing, curling and necrosis at the tip of the leaf blades. With time, whole leaf blades show symptoms and eventually wither and decay. Infected roots are dark brown, flattened, transparent and sometimes hollow. When affected bulbs are cut vertically, they show a watery brown discoloration of the outermost layer of the stem plate, which may progress up through the storage leaves. White mycelium of the fungus may colonize the stem plate and eventually root may rot completely. Infected plants can be pulled easily because of their stunted, decayed root system. Infected bulbs may show no decay at harvest but rot in storage. Next, we will learn about the epidemiology of the disease. Optimum temperature for disease development is 27 degrees centigrade and infection is limited when temperature are below 15 degrees centigrade. Onion plants can be infected directly by the pathogen at any stage, but injury to the roots, the basal plate or bulbs by onion maggots or other insects appear to increase the incidence of this disease. The fungus can persist in soil as resting spores called chlamydospores for several years. Spread of the fungus often occurs by movement of infested soil on equipments, in irrigation water, or on infected onion sets. Now let's see how to manage this disease. Loss can be minimized by following crop rotation with non-susceptible crops. Symptoms are reduced at storage temperature between 8 degrees centigrade and 15 degrees centigrade, but at 30 degrees centigrade the tissues decay and dry rapidly. Fusarium bacillate rot is most severe in poorly drained fields where onions have been grown for several years without adequate crop rotation. Mechanical injuries should be avoided during harvesting and handling, and proper curing is recommended. Treatment with Benomil 0.025% effectively inhibits the fungus. Bulb treatment with potassium metabisulfate 100 ppm, 2,4-D 100 ppm and acetic acid 100 ppm has been recommended. IIHR yellow has some source of resistance. So this is about the management of the disease. Next important disease is the onion smudge. It is caused by Coleotrichum cercinans. Now let's see how the symptoms looks like. The disease occurs late in the season as the crop matures and continue to develop on bulbs in storage. The fruiting bodies of the fungus turn from dark green to black as they mature, and from concentric rings around the neck and on the surface of dry outer bulb scales. If the humidity is high, the disease may spread to the inner scales, causing small yellow lesions. If the disease continues to develop, the bulb may shrivel and sprout prematurely. Under warm, wet conditions, this fungus can cause damping off and leaf spotting. Let's see about the epidemiology of the disease. The fungus can overwinter in the soil and can be introduced on infected bulbs. Warm, moist conditions favor conidial production, and wind, rain plus spread the conidia. These conidia infect mature bulb scales and cause disease when free of moisture. Optimum temperature of 20 to 26 degrees centigrade is favorable for infection. Let's see how to manage this disease. First of all, crop rotation. Use clean seed or healthy transplant seed to reduce disease severity. Yellow and red skin varieties can be used in areas where disease pressure is high. The use of healthy transplant as well as crop rotation for several years can reduce disease severity. If white cultivars are grown, harvested bulbs should be protected from the rain and cured quickly with forced circulation of warm air at 48 degrees centigrade until the outer scales are completely dry. Harvesting onions during dry weather and curing them quickly at the proper temperature and moisture can reduce disease incidence. Crop may be sprayed with 0.2% mancozeb at 7 to 10 days interval. Chemical treatments of the bulbs before storage may be done with 0.2% Captan, Thiram or Captaphon. So this is all about the important fungal diseases of onion. Next, we will learn about the bacterial diseases. First is the bacterial soft rot. It is caused by Pectobacterium keratovorum. Synonymous is Arwenia chrysanthemi or Dickeya chrysanthemi. Bacterial soft rot is a major post-harvest disease of onion bulbs, and several types of bacteria are associated with post-harvest decay through secondary infection. Only Pectobacterium keratovorum and Dickeya chrysanthemi produce pectolytic enzymes and can enter a bulb without pre-existing injury to cause the specific disease known as soft rot. Next disease is the sore skin, and the causal organism is Burkholderia cepacia. Synonymous is Pseudomonas. Sore skin is a scale rot of onion bulbs accelerated by excessive water and nitrogen before harvest. Over maturity, wounding, moist condition at harvest, and temperature over 30 degrees centigrade. The bacteria can enter the plant through wounds in young leaves and progress down the leaf tissue to rot the bulb scales. Infected leaves develop a light brown, watery rot in the onion neck. Infected scales are slimy and yellow, and the upper portion of the bulb can shrink. So, this is about the disease. Next disease is the slippery skin. It is caused by Burkholderia gladuli subspecies Helicola. Intact onion bulbs with slippery skin can appear disease-free until they are cut open. However, the inner scales of the diseased bulbs are brown and water-soaked, and bulb turns soft and rotten. One indication of slippery skin is when the inner core slips out when pressure is applied to the base of the bulb. As with the sore skin disease, bacteria enters through the leaf tissue and infection progress down to the bulb tissue. Mature bulbs are highly susceptible to B. gladuli subspecies Helicola and can rot entirely after 10 days at room temperature. Slippery skin can be differentiated from sore skin in that sore skin primarily attacks the outer fleshy scales. So, this is about the bacterial disease. Now, let us see nematode disease. Nematodes like the southern root knot nematode Meloidogyna incognita can be a serious pest on onions grown in sandy soils under high temperatures. However, nematodes are generally considered minor onion pests compared to fungal and bacterial pathogens. Plants infected with root knot nematodes have slow growth, reduced bulb enlargement, root proliferation, slight root galling, root deformity, and chlorotic leaves. So, this is about the diseases of onion and its management. So, now we are in the conclusion of the topic. Onion is attacked by large numbers of pathogens causing different type of diseases. Among these, most important ones that cause extensive crop losses are downy mildew, purple blotch, botrytis rot. Other diseases are localized in some of the geographical areas, causing more or severe loss to that particular area. The most effective and sustainable control of the diseases will be obtained when different management strategies were integrated together. If proper management and cultivation practices is followed, starting from seed collection, sowing to harvesting and storing, then loss can be minimized.